Hello everyone, let us continue our discussion with the next topic and the advanced capabilities of 8.0.11. Okay, so the first one is called the adaptation or some said adaptive modulation encoding and other things. Okay, and before that, I have to mention that this red adaptation technique is not on exclusive only to the 8.0.11, but also to other wireless technologies. For example, even in 3G from HSPA and 4G LTE and then other wireless techniques also have this kind of capabilities. So basically, what happened in this red adaptation is, as we have seen before, there are two important parameters in the wireless called the SNR and BER. So SNR is something that is varying depending on the signal strength and more specifically depending on our position or our distance with the base station. When I say our, it means like the wireless node or the wireless terminal. Okay, so the distance or the position of the wireless terminal or wireless node relative to the base station. So the closer it gets, the higher the SNR, and the farther it gets, the lower the SNR. And also, it also like affected by if there's obstacle or not between the base station and or access point and the wireless nodes and so on. Depending on that, so we may get the higher or lower SNR. And the BR is something, or bit error rate is mostly something that is depending on the specification of the device. Okay, so the device might be able to tolerate BR, let's say in 10 to the power of -5. Okay, and above that it is not able to recover any error. Or any other device is more sensitive. So for example, it's the maximum error rate is 10 to the power of -6. Okay, so this is depending on the specification of the device. So basically, we have to be able to adapt on the physical layer modulation techniques and even the coding techniques. Okay, in order to because sometimes we are moving closer or getting far away from the base station, and consequently we are receiving less SNR or higher SNR. So we have to be able to maintain the required BR. So how to do that? We are modifying, or we are changing our physical layer modulation technique as we are moving. Okay, so for example, like in the first, okay, so this is let's say in the first in the initial state, we get for example like this 30 dB SNR. So let's say we are very close to the base station or access point, so we receive higher SNR. So we can use the highest modulation technique, which is QAM 256. So this is 8 bits per symbol, so 8 megabit per second. But this is not really true. Okay, the most correct thing is the most correct saying is the 8 bit per symbol. Okay, so let's say in case of we are moving further away and our receive SNR is decreased into, I don't know, let's say this is around 22 dB of SNR. If we are keep using this QAM 256, then we are receiving a lot of, or we are getting a lot of errors. Okay, so the error rate is very high because why is it high? Because with 256 we are using 8 symbols at 8 bits per symbols. So the chance or the probability of getting error is very high, becoming very high, because we are we combine in one symbol there are 8 bits. So so just 1 bit error, then we get a lot of errors. And so it doesn't matter whether we have one error in 1 bit or errors in all the 8 bits. Okay, so just calculate so how many errors that we probably will get. So the option is that we can reduce our modulation techniques by a lower modulation technique like the QAM16, which is using 4 bits per symbol. Then in this case we can get we okay, we can still get we can still get the BR required BR. Let's say it was here, then we can still have this. Let's say below 6 to the 10 to the power minus 6 BR. So this is still okay, right? But then again, in case of the receive SNR is again decrease because we are moving further away again from the base station, then we have to choose a even lower modulation techniques, because then in this point we are not meeting the required BER. So in this case we have to choose perhaps this BPSK, which is just the most basic modulation with 1 bit per symbol. Okay, so this is the lowest possible data rate that we can get. All right, so then the next capability in 802.11 is the power management. Okay, so this power management also uh, become the features of other wireless technologies, but then perhaps they have different techniques or they have different implementation on this power management. Okay, so in 802.11, the node to AP, so node, if the node wants to sleep, so node sends a message to AP that, okay, it's telling that I'm going to sleep until the next beacon frame. Okay, so this beacon frame is something that is periodically sent by the AP to the wireless nodes in its, let's say, in its area. So by receiving this message, the AP knows not to transmit frames to this node because the node is going to sleep. And then the node wakes up before the next beacon frame. So and the beacon frame itself contains a list of mobiles with AP to mobile frames waiting to be sent. So basically, if there's any data to be sent from the AP to the mobile, then the mobile would, I mean, this is something like the advanced notification. Okay, so the node will receive this advanced notification. So the node has to be ready to receive any data from the AP. Okay, so let's say after the node wakes up and then before the next beacon frame, and then it receives the beacon frame. Okay, so if there is the node is in the list of AP to mobile frames to be sent, then the node will stay awake because it knows that it has to receive a frame or any data. But then if the node is not in the list, so it will sleep again until the next beacon frame. So in this way, the node can save some power because in wireless power is very important requirements. It not only important to to transmit data unit powers, but then also because not most of the wireless device is on relies on the battery. Okay, and the more we use the power, then the faster the battery will going off. All right, so I think that's it for the Wi-Fi or 802.11 standards. Then we will continue our discussion or our talk with the cellular technologies in the next video. So see you again in the next video.